All right, welcome back to RAD Factory 3D. I'm Trace, and in today's video, we're going to be designing a small light for a washing machine control panel. This part's no longer available from factory, so we're going to have to make it ourselves. And the material I'm going to be using, I've actually got it in the dry box right now, so I can't pull it out and show you, is Overture Clear PETG. And I'll do a few settings tweaks just to optimize the clarity. And I'll be sure to review the few changes I make to the settings profile. That way you can see exactly how I get where we get with all of this. So let's get started. Alright, so to get started, one of the things you'll need is a set of calipers. Super useful tool. Anytime you do any real world modeling, you'll definitely need a set of these if you're not using a 3D scanner. The other component we're going to need for all of this is the light. So for those of you who don't know what this is a small electronic bulb for the inside of a control panel on a washing machine. So all this does is illuminate the light when the door is locked. And the little lens that goes in this little hole here is actually what secures all of this to the front of the control panel. So without this lens, this little light just moves around in there, doesn't stay in place, and you don't know when the door is locked. So what we're going to have to do is model a lens that fits in the diameter of that circular shape down in there. And the way this is going to work is this lens has to be pretty tight tolerance to that circle there. And what's going to happen is it's just going to slide up this channel and snap into place. And all of this has just a little bit of flex to it. So we don't have to worry if our tolerance isn't super close. So stick that into there like that. And you know what I'll do for you? Bump this back up. All right. So you can really see what I'm doing. Excuse my crusty hands. Today was a work day for me. If you're curious, I'm an appliance technician by day and a 3D printing technician by night. So what I'm doing is I've got my tool inserted and I'm just kind of rotating it a little just to be sure I've got the tightest measurement against those two gaps in there. And really that's the only measurement we'll need for right now. So let's take a look at that. I'm looking at about 6.55. We can do 6.6, so it's a little tight. So the next thing we're going to have to do is figure out the depth that we'd like here. And the way I'm going to do that is I'm just going to eyeball about 1 millimeter below this little lip down here. So we're going to go about there. Yeah, that's good. And what we're doing is we're going to measure the length of the light from where it hooks in to the control panel. It has to pass through a piece of metal. And these two tabs are what secure the light in place. So we need to be just barely below that and barely above it. So we're looking at 8 millimeters total. So the last thing we're going to want to do is we're going to look inside of here and we're going to determine the width of the lip we'd like. And this is kind of the hard way. What we can do is using the software is just add 1 millimeter diameter to the sketch of the bottom of our cylinder we make for our body. So let's get to modeling. So the software I'm using is Shapr3d. I haven't decided if I'm going to go with Fusion 360, Shapr3d, SolidWorks. There's a couple others. I want to do some more testing with all of them to decide if there's one I like more than the others. Shapr I like just because it's simple, it's easy, and it's nice to look at. So where we're going to start is with our first dimension. And make this easy on ourselves. Dead center top. Start with a circle. We're going to go 6.6 millimeters in diameter. Let's extrude this 8 millimeters. And let's add our securing tab. And like I said earlier, we're just going to do this the easy way. We're going to use a circle. This diameter is 6.6. And we're going to go 7.6. Yep, just like that. Sick. Okay. Exit sketch. Grab your ring. And this only needs to be 1 millimeter thick. That's enough to hold it. Right now I'm trying to decide if we want to add a millimeter in depth or if we want to slide this inner cylinder down to meet this and then unionize the two components. I'm just going to add the extra millimeter. There ain't going to be no problem with that. And we'll just pull this down to be flush. Cool. And I like to just get this out of the way early. Control A. Start typing union. And join those parts just so I don't forget. I've sliced so many files where I find little pieces of little triangles, rectangles, circles laying off to the side when I hit arrange parts. So the final feature we need on this, we're really almost done, is the lip across the top that secures this to the control panel. So the way this works is this lens goes in through the front, and this lip rests on the metal of the control panel, and then the light I showed you earlier hooks onto this lens from the back, and that's how all this stays in place. So now we're going to do this, add another sketch, take a peek at my notes. Circle. And we're going to go with a nice, this is just aesthetics now, this lip. Part of it secures it in place. The rest of it is just for how much of a bezel it has around the hole. We're just going to go with a nice round 10. Peek at my calipers just so I could kind of eyeball what that looks like. To do this, now I'm going to make sure I select this outer surface and the inner surface of this other cylinder. I'd like this to be flush across the top. Extrude this. I want this just a hair shorter. We're going to take this to 3. Take this surface down to 10. To make this nice, and just so the light doesn't move around, I like 0.5. This one doesn't really need it. This one I actually wouldn't do it on just because it may cause the light to pop loose from the lens easier. And now we're just going to play around with this top edge just to kind of get a nice aesthetic feature on the outside edge of this lens. I like 0. Take a quick look over. And I really like that. I think that looks good. All right. Now let's export this out of here and import it into Cura. So the way I prefer to export files out of Shapr is doing them as a 3MF.
And if you have multiple components, I always check this box. That way it saves them each individually as individual components in a folder, and instead of each individual component being in the same file. So that's one thing I really like. Export this as RAD Factory lens. Sick. All right, pop over to Cura, File, Open Files, RAD Factory lens. Range all models. Go over to Prepare. Sick. There we are. Our light. Lens, excuse me. So, like I said before, generic PETG profile in Cura. The settings I've changed in here are I reduced the wall count just so I also increased the flow rate. So all those little gaps in the infill will hopefully be taken up by that increased flow rate and the lower speed. So I'm trying to get as thin a walls as I can without compromising surface quality. Don't think I altered any top bottom settings. Infill, put to 100% lines. It's always best. Defaults to lines there, so you don't have to change anything else. Material printing temperature, I tend to go a little hotter for clear PETG if you're trying to get that really transparent clarity on it. Of course, the higher you go on temp, you start getting those funky abnormalities. So just be aware of that when you start increasing your temp. Flow, like I said earlier, I do at 102%, just so it gets all those little tiny voids filled up nicely. Printing speed, I printed my first test at 30. I feel like it maybe was a little too fast, but I'm concerned my extruder won't be able to extrude properly at these speeds below 15. So I'm going to leave it there. And I always like a nice round 1mm retraction and a nice good 30, but I'm actually going to bump this down to 25 because I saw a few, what happened here? I saw a few strange things, little marks that I kind of didn't like on my first test, and I think maybe because my retraction speed was a little too fast. Number lock, 25. We're going to go with that. Combing mode within infill, just so there's the least amount of abnormalities on the surface. Won't really affect the top, but I always like it. You know, cleanest outer surface you can get. Cooling, I always set this to 30 for PETG. I'm not 100% sure why it's not that. Maybe that's some of the abnormalities of my first test too. Generate supports, normal settings are fine. I generally like a support angle of about 50 with PETG. This is pretty much a 90-degree angle, so that's kind of irrelevant. Remove mesh intersection, just in case I've got any weird things with how I put this top piece on the main cylinder. I guess nothing in here, but one thing I know I set that I didn't tell you about in infill was connect infill lines, just so there's the least amount of extrusions, the least amount of possibility for voids and small holes in the part. Set slice, take a look at it. 15 minutes, sick, 1 gram. That looks okay. All right. And now we're sliced, and now we're ready to send it off to the printer and see what we get here in about 20 minutes. Alright, so here's our part. I think it turned out really great. The surface quality is really great, and if I can get the camera to focus, if you look at the bottom, if I get it all the way down, it appears to have a hollow center, which it's actually at 100% infill, which tells me we've succeeded in creating almost the clarity we'd like here. It's not quite as clear as I'd like, but again, all we need is for this to illuminate orange, and I think we'll succeed in that. So here's the part installed, and man, that looks really great. I think we've achieved our goal. We've replaced the lens and it's illuminating orange, and I've seen these lenses before. I actually think that our lens might be a little brighter, so I'm really happy with how this turned out.
So I had a lot of fun making this part. I was really happy with how it turned out. If there's something you think I should have done or could do better, please put that down in the comments. I really appreciate you stopping by and checking out this video. I'm sorry it was a little long. Please hit that like button and consider subscribing. Thanks.